Alright, so we are working on 5.4, right? Linear equations in standard form. If you still have your little handout, that was going in your spiral notebook. I've not glued mine in yet because I'm still writing on it. But we are now to the last part, that is your standard form. And you can be filling this out as we go along. Remember, we fill these out, we'll end up gluing them in our spiral notebook. You should be finished with it today. So we can put in, this will be our good review. Because if you're looking ahead, you're going to see day 6, which is going to be Monday, is a review. Which means we're quizzing on Tuesday. Okay, so the first thing, we're going to look at our warm-up. It says, write an equation in point-slope form of a line that passes through the given points. Okay? So we look back at point-slope form, and what they're asking us, point-slope form, remember, is y minus y1 equals m times x minus x1. So how do you think we do number 1? Katie? Good. So I'm going to still write y minus, and I'm going to replace it with y1. So we're going to say 4 equals m, and then we have x minus 1. But wasn't there something important that we have to remember? Something else? Switching the signs. Remember, when we go to this point-slope form, I have to keep looking at the word because I want to switch the names around. Point-slope form, our signs are opposite. So, yeah. Oh. It is already named opposite. See, I knew I was going to mess with it. What? Hold on. Y minus 4 because it was a positive 4. And then x minus 1. Yeah. So we're okay right here. The signs are opposite what they were. Okay, what do we do now?
Take a gander. Do we find the slope?
We can find the slope. Okay, how do we find the slope? Alex? Okay, so we have all these terms that we're trying to remember. Oops. So in this equation, we'd have our negative 1 minus 4, and then we'd have 6 minus 1. So our slope would be negative 1 minus 4 is negative 5 over 5. So our slope is now negative 1. Okay. So I've written it in point slope. I've done my slope is negative 1. What am I going to do now?
Substitute negative 1 for m.
Okay, let's switch colors so we can start to see. I have y minus 4 equals negative 1 x minus 1. Okay. What am I wanting to do now? So we've done a lot of work, but what has this done for us? one has it? Okay, so what are we going to do to solve? I'm going to go ahead and say I'm going to do my work over here. So I have some room. I have y minus 4 equals negative 1 x minus 1. Okay, Zoe?
Why do we have to solve
So am I done? Is it in point so form? That's what I'm asking.
Yes.
So what do I have to do now?
Circle the answer.
We're done. This is in point. I want you guys to start thinking about what's going on. But it said in point slope form. So this is point slope form. That's what it's showing us. So we can have that. Now, what I do want to do, because I heard some people say let's go ahead and solve it. Point slope form is, to me, a lot more confusing to write our line. So we could go ahead and go to slope intercept form. And remember, that one's the one that's just the y equals mx plus b. So if we were to do that, we could go ahead and solve for this. All you have to do, and this is why these three forms are all going to work with each other, is I can go ahead and distribute this. This would be y minus 4 equals negative x plus 1. Okay? I then have to add 4 to each side. And I have y equals negative x plus 5. And then there's our slope form. So it's pretty easy to go between the two. Remember, yesterday I was talking about our point slope form. And I don't really love that one. And typically that one's used like in story problems. It's a good way to solve some story problems. But when we're doing our actual work, slope intercept form is a lot easier. All right, I'm going to skip number 2 for right now, our warm-up, because I just want us to get started on our lesson. So I might come back and do our video later and add to our warm-up, but let's get started with today's. It says, I can write an equation in standard form. I'm going to preference this. I've been practicing it, but I know I keep making little mental mistakes. That's how I do math. I make a mistake, and then I go back and fix it. So I hope I don't do that now. But I can write an equation in standard form. So that's our third one. What is standard form? We have another formula to remember. Standard form is ax plus by equals c. Okay? Obviously, we're using a lot of variables to stand for other things. We're still having our x and y, which is similar, but we'll put another variable because we can have a coefficient in front of x and y that can be anything. The rule, though, is a, b, and c are integers. Once again, what are integers? Whole numbers, but they can be negatives, right? Integers are like positive 5, negative 17. They cannot be decimals, they cannot be fractions. Both a and b cannot be a 0. I think this is what we're writing in our standard form. Oh, I don't know if that's... No, it's anyways. A must be a positive. So we want to make sure that this first one is a positive number. We can have no fractions and no decimals. And we're going to see something here when you're going to first go to solve it. You're going to be like, oh, I get rid of a fraction. It's actually fairly easy. All right, so in your little foldable flap, we have options 1 and options 2. And we have, this is standard form. Right here, this is standard form. 2x minus 3y equals 6. I know it's standard form because my x and y are on the same side of the equal sign. They're both integers, and my a, for right in front of the x, is a positive 2. It's a positive number. So we have to graph this. Okay, there's two ways we do it. Option one, we change it into slope-intercept form. So I have 2x minus 3y equals 6. Remember, slope-intercept is y equals mx plus b, where this is your y-intercept, that's your slope. So what do you think? How am I going to go from 2x minus 3y equals 6? How am I going to get that in a slope-intercept form? Grace?
First, you have to subtract 2x.
Alright, so we want to get that y by itself. So I'm going to minus 2x. So I have to do that on both sides. I show every one of my steps. So I have negative. I should have wrote this whole thing. I'm going to move it all over so we have room to work. So I have 2x minus 3y equals 6. Like Grace said, I'm going to minus 2x. So now I have negative 3y is negative 2x plus 6. Okay. I'm not quite in slope-intercept form yet. Maddie?
Divide by -3.
Good. We want to get y as a positive. So I'm going to divide by -3, but that means everything over here is divided by -3. Do not make that mistake. So I have y, and then if I have negative 2x divided by -3.
It would just be 2
Okay, so 2x, negative 2x divided by 3 gives me 2/3 x. And 6, positive 6, divided by -3 gives me negative 2. So now I have y equals 2/3 x minus 2. Can we graph that?
Yeah.
Okay, so what's the first thing I should do to graph it? I have slope-intercept form. Tatum? Good. We look for our y-intercept first, which is right here. So we're going to look at -2 is our y-intercept. So I go down. I'm going to use a different color than black so we see it easy. Right there. There's my y-intercept. Remember, y-intercept, your x is always 0. We found where it crosses the y-axis. Okay, so now what do I do? Maddie?
You have to go up 2 and to the right 3.
Good. Remember, our slope is rise over run. So it told me to go up 2. Let me use grades so I can show 1, 2. And then I have to run those 3. 1, 2, 3. My new point is right there. Can I do another point? Yeah, I mean, I can continue doing this now that I have slope. I can go forever. 1, 2, 1, 2. It's going to go off the chart. So it's going to go over here somewhere. I could go back to the original one and go opposite. Down 2, left 3. Remember your slope, if I flipped it to the negative, it's just going to go on the other side. And then the last thing I do is, because it's an equal sign, that means we have no limitation, which our line will go on forever. We don't have to put the ray, we don't have to do the segment. And remember, we only do rays or segments if we have inequalities, a less than or equal to or not more than. So I'll draw my line. Then I use my mouse to fix my mistake. It was close to beautiful. Ooh, that one's real close. Oh, it was there. There we go. And there we have graphed that line from standard form, we went to slope-intercept form, and we graphed it. Devlin?
So if the line keeps going infinitely in either quadrant 1 or 4, then the slope would be positive. But if you keep or positive or negative, depending on well, it'd still be positive because they both be negative. It goes infinitely in just one.
It's a positive slope because it's slanted up to the right.
I know, but also when it's slanted down.
But remember, for our
that would
negative,
make the delta y and delta x just negative. So the two negatives should cancel out, which would still give you a positive slope.
yeah, that's why we still call this a positive slope.
So
Even though the line can go left, because we're going continuous in there, it's still not positive slope. We always call this a positive slope.
okay, and then the negative slope would be quadrant.
Negative slope is going to be like this. Okay, now, option 2. Option 2 is fairly easy as well. We're going to find the intercepts. And so I have to find my x-intercept, and then I have to find my y-intercept. And to be honest, this is where standard form is kind of handy. It's pretty simple. Anything for my x-intercept, we should remember my coordinates for it have to be what? What's one of the coordinates I know for sure if I'm finding x-intercept? Which one's 0? Yeah, y has to be 0. So if I go down to y-intercept, I know my x is 0. To find my x-intercept, I just take this equation, 2x minus 3y equals 6, and I set my y to 0. So 2x minus 3 times 0 equals 6. Let's switch colors so we can see what we're doing. This would simplify, well, negative 3 times 0 is just 0, so I'd have 2x equals 6. And then divide by 2, and we get x equals 3. My x-intercept should be at 3, 0. Well, let's check our graph. We had 1, 2, 3 right there. We actually had that one. We go to do our y-intercept. X is 0. We do the same process. 2x minus 3y equals 6. We replace x with 0. So 2 times 0 minus 3x, or 3y equals 6. 2 times 0 cancels out, so I have negative 3y equals 6. Divided by negative 3, y equals negative 2. And if we look, we had 0, and we had that negative 2. And then you could just connect your 2 points. So when we are asked to graph from standard form, you can do it either way. Go to slope-intercept form and solve, or you can just find the 2 intercepts. This goes in your foldable. And I'm not going to wait a long time for us to copy this, just because you can go back and do this, and I think you'd rather have some work time. But recognizing standard form, x and y are on the same side of the equal sign. The coefficients of x and y are integers, okay? And the constant, there's a constant on the other side of the equation. What that was just saying, if I go back up to here, kind of what we already said. X and y are on the same side. A and b have to be integers. They cannot be fractions or decimals. And the constant is on the other side. It's just a number. 2 options to graph, which we would write down. We just said convert to slope-intercept form and find and graph the x and y intercepts. So we've done this. We should be okay there so far. Here's where it's going to get a little bit tricky. Write the following equations in standard form. Remember, no fractions, and a must be positive. They've given us y equals 2/3 x minus 1. I need to write this so it is in standard form. ax plus by equals c. So I know I have to get my x to the left side. Mainly, right now, that's the first thought I have. This ends up having to get over here, and I'm done. But if I minus 2/3 x, my answer is negative 2/3 x plus y equals negative 1. That's not standard form because x is a fraction. Any ideas on what we do to solve this? Good, you're on the right idea. Times by the reciprocal. If I multiply by 3 over 2, though, I'd have to do that to negative 1, so I'd get negative 3/2. But I'd also have to do it to the y, and I'd get y as a fraction, 3 over 2. So that'd be a problem.
Multiply by the denominator.
Multiply what by the denominator?
Everything. If you do times 3, then you get 2.
All right, good. So let's do that right now.
2 and negative 3.
I'm going to take on each side of the equal sign, very close to what you were saying about the reciprocal, but we're only going to multiply by the denominator. So I'm going to multiply all of this. We have to distribute. We can't do it to just one of the terms because there's 2 of them on this side of the equal sign. And I'm going to times this whole side by 3, which means I have to go on the other side of the equal sign, and I also have to times it all by 3. So let's do the first one. That one should be easy. 3 times y would give me 3y equals, but now here I'm going to show my work over here. If I have 2/3 x, and I'm multiplying by 3, we can say that's like 3 over 1. We know that our 3's can cancel each other out. So what would I be left with?
2 over 1.
There you go. Thank you, Ron. 2x. The x can't go away. We still have to make sure we throw our variable in. I just want to make sure, I know you guys are probably thinking that, but I don't want us to forget about that. And then I have negative 1 times 3. So I distributed it here. Now I'm distributing there. Negative 1 times 3 is?
Negative 3.
So we're done with our distribution. Now we have whole numbers, and I'm going to go ahead and minus my 2x, and I get negative 2x plus 3y equals negative 3. I'm going to erase some over here so I can rewrite this equation. Negative 2x plus 3y equals negative 3. Okay, so am I done now? I got my x on the side, I got my y on there, they're both integers. I'm good? No, there's something wrong. What's wrong?
It has to be positive.
Which one has to be positive?
The 2x.
So, how do I make negative 2x a positive?
Give it love and support.
Give it love and support. That's very close to the answer. Devlin?
And make all the positives negatives. Negatives positive.
In reality, what we're going to do is I could switch all the signs. I could just say, okay, this is going to be positive 2x, this is negative 3y, and then this is positive 3. In reality, that's what's happening. Mathematically, what we're doing, I'm now going to times this whole side by negative 1. So I have to times this side by negative 1. Remember, we times by 1, that's the identity property of multiplication. The numbers stay the same, but since I did a negative, it just changes the positive and negative. It would be 2x minus 3y equals just 3. And then that is our solution.
Why would you change it to minus 3y? Because it's no longer possible.
Because I'm doing negative 1
You're adding up negative.
times positive 3. Yeah, remember that sign, you could have said 2x plus negative 3y.
But it's just the same.
But that's just the same. Adding a negative is the same as just saying subtracting a positive. So, let's go ahead and have you guys start. Try and do this one. Now that you know how to do it, it should be just a matter of will I do my work correct.
Mine didn't load correctly.
So I have y equals negative 1/2 x plus 5. Let's pick on somebody. See if they understand this. Oh, Zoe, you made eye contact. That's not good. Zoe, what am I going to do first?
To get it to be a whole number, you have to multiply its denominator.
Good. So we're going to do this whole part then, remember? Everything over there by 2. So everything over here. Ooh, what?
Negative 2. Skip a step going back.
Okay, you could, but here's the problem. If I do this, I'm going to think way ahead, right? You're trying to think ahead. You're saying, if I times by a negative, it'll give it a positive, which we need. But when I move it to the other side, that positive will become a
Negative.
So then I have to do another thing.
Negative on here. It doesn't show anything.
So, we're going to multiply by 2. 2 times y is 2y. And then I'm going to distribute. 2 times negative 1/2 will leave me with just...
No, I don't.
Oh, what?
I know you probably just explained this, but since it's negative 1/2, wouldn't it be negative or times negative 2 or?
Okay, so you can, so the reason I don't look at it is because I look at the ones negative,
Okay.
and it doesn't really matter. I could say this is a negative 2 and do this, and it'll all work out. But to be honest, I'm kind of cheating and thinking ahead. If I do a negative, I'm going to get a positive x left, right? I know that x has to move the other side of the equal sign, so then it's going to become a negative x, and it has to be a positive x. So then I'll have to times by -1. So I'm thinking I want my x on the right side to be negative, so when I add to the other side, it's already a positive. So I'm kind of cheating. I guess I shouldn't have done that, but if we go with this, we'll do negative, and I'll show you why. So it's negative 1/2. Let's times by negative 2. So negative 2 times 1/2 would just give us x. Negative 2 times positive 5 gives us negative 10. Then we have to get x the other side. So this is where I minus that x and minus x. So now I have negative x plus 2y equals negative 10. But remember, our first term, that a in front of the x, has to be a positive. So now it's like I'm taking all of this times -1 and this times -1. And so then I would have x minus 2y equals 10. Which time do we have?
4 minutes.
Okay. Because of time. Okay. Because of time, I'm going to go real quick. I'm just going to explain. We're not going to do this whole part. But on this one, first thing you think you have to do is what? What's the first thing I'd have to do? Nope.
You have to distribute the...
We have to distribute. This one should get written out as y minus 9 equals half times that x is half x. Half times -3 is,
-1.
or I'm going to leave it as my improper fraction. Then I'm going to go ahead and do all the steps we have. I want to make sure we can look at this next problem. So, if you guys want, after class, I'll go ahead and I'll work the problems we don't finish in this. And I'll make a second YouTube video. I'll say, like, I'll post today's lesson, and then I'll post another one that says, problems we didn't finish. But This one's really simple. Write two equations in standard form that are equivalent to 2x minus 6y equals 4. This is the same thing as fractions. You remember how I have 1/2 as a fraction? How do I make an equivalent fraction? Times it by anything, mainly, right? If I did 1/2 times 2, I get 2/4. I could times it by 3 and get 3/6. I could times it by 10 and get 10/20. I'm going to do the same thing here, but we just have to make sure you distribute it to everything. My first thing is, I see the numbers 2, 6, and 4, and the first thing that goes off in my head are, they're all even. Can I divide each number by 2?
Yes.
If I divide this whole thing by 2, I'd be left with x minus 3y equals 2. There's one equation that is equivalent. So I'm done that. So now, Alex, what was the other thing I could have done? Sure, I could have done 2x minus 6y equals 4. And we could have just said, let's multiply this all by 2. So I have to do this side by 2. 2 times 2x is 4x minus 12y was 8. There's another one. If you want to be a smart aleck like I was in school and always made Mr. Stolzenberg mad because I made a smart comment that I can get these done in like no time, I always times by 10, 100, 1,000, 10,000, 100,000 because I could just add zeros to the end. I didn't have to really do any math problems. He's like, oh, smart aleck. I was like, you saying. But making equivalent fractions here, or fractions, equivalent equations, it's just that. You have to make sure the only problem I see happening, the biggest thing I see happening is either 1, we only do it to one side, or 2, we only do it to one of the numbers. Remember, if I times this 2x minus 6y, the 2 has to go to both parts. Alright, I will, because I know there's another one that's talking about graphing, I will finish this and post it. Your homework is out of the textbook. Have a great weekend. Check this.